Hello, friends. This is Jim with Science Talk. This is going to be the first of two videos, but I'm going to in each of the two videos, I'm going to look at a slightly different aspect. We're going to be discussing how the huge die-off during the Permian era may hold some warnings for us today. Okay. So, what happened during the Permian era? Well, it was a mass annihilation. Well over 90% of all organisms died. Something like 96% in the marine system perished. So, the mass annihilation, the mass extinction rate that happened then, has lessons for climate science today, which are not encouraging. So what happened at least in the marine system? Well, they found themselves increasingly in hot water. They died of overheating or suffocation as the ocean temperatures and lake temperatures increased. Rapidly warming globe, marine animals simply were not able to take in enough oxygen. And they died in the billions. Remember, as you increase the temperature of water, the solubility or the concentration of gases decreases. And organisms that live in aquatic systems, they obtain their oxygen not in gaseous form, but it's in dissolved form. It's actually dissolved in the water. And their gills, through diffusion, separates out the oxygen so that they can respire, etc. Increase the water temperatures, the oxygen concentration goes down, so there's less and less oxygen available. The organisms basically soon are suffocating. Now, scientists working on that Permian extinction have reconstructed the events, and what they say as the prime cause of mass death was a dramatic rise in atmospheric CO2, which raised tropical ocean temperatures by 10 degrees Celsius. That's 18 degrees Fahrenheit. Think how much energy is required to input into an aquatic system to raise this temperature 1 degree C. Now we're doing this 10 times. That's a shitload of energy, to be blunt. Now, tropical species can move away from the equatorial zone. They can go to the temperate latitude where the water temperatures may be cooler, so the concentration of oxygen will be a little higher. But where do the temperate organisms and organisms living in the high latitude, where do they go? They die, is what happens. So, Curtis Deutsch, who's an oceanographer at the University of Washington, states that very few marine organisms stayed in the same habitat they were living in. It was either flee or perish. His co-author and colleague Justin Penn sees a warning for today in which temperatures have begun to rise in response to the widespread burning of fossil fuels. Under a business-as-usual emissions scenario, by 2100, warming in the upper ocean will have approached 20% of warming in the late Permian. And by the year 2300, will reach between 35% and 50%. This study highlights the potential for a mass extinction arising from a similar mechanisms under anthropogenic climate change. So, now 20% of warming, that's basically we're at 2 degrees right now. So, the latest study is unlikely to close the case Carbon dioxide buildup in the atmosphere has been proposed before, but other teams have suggested dramatic ozone loss in the upper atmosphere as a prime cause of death for the Permian. Other possible factors that leading to this mass extinction event: increasingly acidic oceans, mass release of metal and sulfide toxin, or complete lack of oxygen. Well, now, increasing acidic oceans. You're warming up the waters, okay? You're putting CO2 into the atmosphere. I've discussed these with you guys before. CO2 plus water makes carbonic acid. It's a weak acid, but still, it's an acid. It will reduce the pH of the water, making it more acidic. So geologists work on the principle that the present is key to the past, and therefore it follows that what happened in the past could be a guide to what might happen in the future. This is why climate scientists attach huge importance to research into ancient atmospheres. Now, I am putting together, and either I will have published this before or after this video, but I am putting together a very lengthy video on isotopic fractionation, where I follow primarily oxygen. I talk about carbon as well. We look at the O18, O16 ratios, the DEL, and use that information to reconstruct past temperatures, past climate conditions. So, Penn and his colleagues report in the journal Science. They made some computer models. They matched the computer models of animal metabolisms and ocean conditions with the fossil evidence from the boundary of the Permian and Triassic periods. They claim they have the first computer-based prediction that could be directly tested against the evidence from the shells and the bones of creatures preserved in strata laid down 252 million years ago. In other words, they were able to reproduce it, so the model is working nicely with the available data, and therefore they were able to reconstruct the pattern of the extinction. Massive volcanic lava flows in what is now Siberia deposited huge amounts of CO2 into the atmosphere. As ocean temperatures rose, the seas began to lose up to 80% of their dissolved oxygen. Half of the deep ocean seafloor became completely anoxic. That means without oxygen. Dead zone at the bottom of the ocean for aerobic life form. If you're an anaerobic life form, you might do just fine. This is now, when this happened, this is the onset of what's been called the Great Dying. The researchers checked the temperature and oxygen readings of what they knew of 61 modern marine species: sharks, crustaceans, corals, mollusks, bony fish, all classes of creatures that evolved under conditions similar in the Permian and to the Permian. Those hit the hardest and most sensitive to oxygen, makes perfect sense, that live far from the tropics. Tropical species were already adapted to high temperatures and low oxygen. All they had to do is simply move elsewhere, and they did better. Now, do conditions at the close of the Permian provide a parallel to the planet today? Difficult to say. Back then, most of the land surface was one huge supercontinent. There were no mammals, no grasses or flowering plants. Forests, the traffic between the atmosphere and organisms would have been a completely different setup. Really completely unfamiliar to what we know today. Even if it represents an extreme case, the lesson is clear. This is a statement from Lee Kump, who is an earth scientist at Penn State University. and he publishes his comments in a commentary in Science. Continued or accelerated fossil fuel burning presents a risk that must be reversed or mitigated so that we can avoid a fate anything like the end of the Permian. So, what's happening here? A little summation. The Permian, there's evidence that the ocean water temperatures rose 10 degrees C during the Permian. This led to massive suffocation and die-off because dissolved oxygen concentration decreased dramatically. Many organisms suffocated. Some scientists want to cite other causes. If they have data to back that up, let's see it. And actually, there's a lot of speculation. I have not seen convincing data for my liking. But we do know about the Siberian volcano just erupting continuously for, I think, well over 100,000 years. Just kept erupting, throwing a lot of CO2 into the atmosphere, hence increasing the water temperature, decreasing the pH, lots of organisms dying off. Now, with the big supercontinent, of course, that's going to affect oceanic currents and flows and heat distribution. Now, I'm preparing a Milankovitch video, and one of the interesting things is in that video will be that once Antarctica moved to its current location, the planet drastically cooled down, along with the Isthmus of Panama forming. And I'll talk, and basically that created the Gulf Stream. Well, the Gulf Stream moves heat from the tropics to the northern latitudes. The warm air is given off to the colder atmosphere, right? The moisture in the warm water gives off its heat energy, latent heat energy, to the atmosphere. It comes down to snow. Enough snow compacts into ice. Glaciers grow. Ice Age. So that's coming soon. But basically, with the Isthmus of Panama and Antarctica, this is when Earth started to really drastically cool down. And we're heating up the planet at rates not seen before. So it was warmer in the past. Too warm for humans. And that's where we're headed. So that'll be the first video talking about the Permian. Stay tuned for the second video. Thank you for your time. Hey folks, this is Jim here reminding you to subscribe to this channel, to share my videos, tell others of the work that I do here. I also ask that if you are not already a patron at Patreon, to please consider becoming a patron at Patreon. You can find the information in the description box below the video. I'm asking you to help support the work that I do. I do not take any money from corporations or from any other sources, so the information I share with you is the actual science as it comes out of the peer-reviewed journals. So there is no BS, there's no propaganda, there's no agenda. It's just I present the science and I explain to you what it means, or at least my interpretations of it, based on my own experience as a scientist. I want this channel to grow. I consider, while I discuss many different topics here, you notice I do focus a lot on climate issues. I consider climate change to be the most pressing issue facing humanity today. Thus, I consider it important to disseminate this information to a wider and wider, more and more people. And I need your help to do this. So, yes, please subscribe. Please tell others of the work that I do here. Please share my videos on social media platforms, with your social media groups, what have you. We need to get this information out there. So for those of you who are supporting me on Patreon, I thank you greatly for your support and continued support. It does mean a lot to me. So, together, we can get this information to more and more people. Thank you. Thank you for your support.